Hey guys, welcome back. This is the second video related to the blockchain for maintaining digital assets code pattern. The first video gave us an introduction to the code pattern as well as a demonstration of the app. I've linked the video in the description below. In this video, we'll see how to set up the blockchain network on IBM blockchain platform. After that, we will deploy the smart contract on the network and connect the network with our application so that we can run it. So let's get started. So this is the repo for blockchain for maintaining digital assets on GitHub. It's currently housed in my personal GitHub org, but by the time you get to it, it will have been moved to IBM's public GitHub org. So the link that I have included in the description below is the one for the IBM GitHub org, and that's going to take you to the correct place where this repo will eventually be housed. So the repo's ReadMe actually walks you through a lot of things such as the introduction to this particular application, the description of it, why it's required, why digital asset management systems are required, why we are doing it using blockchain, how we are doing it using blockchain, the different kinds of actions that can be performed in this application, and so on. It also walks us through a list of steps that we'll have to perform in order to set up this application. It gives us the architecture flow that explains what happens at each and every step of setting up of this particular application. So let's scroll down to the running the application section and let's see. So the first step it says over here is to clone the repo. So let's grab this link from here, and by the time you come back to this and try it out yourself, this link will have changed to IBM because this would have moved to the public IBM org. So let's go to a terminal, and in a folder, let's clone this GitHub repo. So now we have blockchain for maintaining digital assets available on our local machine. So now in VS Code, let's go in and open the contract folder within this repo. So in the local copy of the repo, which is blockchain for maintaining digital assets, let's open the contract folder and click open. Remember to open the contract folder and not the main repo folder, because otherwise when you package the contract, it's going to throw some errors. The contract folder has now been loaded into VS Code. The next step, as per the instructions on the GitHub repo README, is to package the smart contract. So let's go to the blockchain platform extension and we can say package open project. And that is going to create the package for our smart contract. And with that, we have exported our package. The next step is to set up the IBM Cloud Services and the Mailtrap server. So let's go and do that now. Let's start by creating the fake SMTP server that we'll be using as part of this application, which is where we would be receiving all the emails sent by the application. So I'm here at mailtrap.io and we can go ahead and sign up. You can use your Google account, your GitHub account, or you could just type in an email address and password and create a new account. I've already connected to Mailtrap using my GitHub account, so I'm just going to use that. Once you've signed up and logged in, you come to the My Inboxes page or the home page, which shows you all of the inboxes that you have. At this moment, I have none, and I will create a new inbox called My Inbox, which is what I'll be using for our digital assets application. Let's click on Create Inbox. The inbox has now been created, and we will be making use of Node Mailer to connect our Node application with this mailbox. So in the integration section, we can scroll down and select Node Mailer. And this is all the information that will be required for that integration between Node Mailer in our application and this particular mailbox. We'll make use of these bits of information at a later stage in this process. It is now time to create the IBM Cloud Services. So I'm here on cloud.ibm.com, and after logging in, I can go to Catalog. We'll start by creating the Kubernetes cluster. So let's go to Containers and select Kubernetes Service. While there are many pricing plans available for Kubernetes service, we are just going to create a free cluster. It expires after 30 days and you'd have to recreate it, but this way you'd be able to have a look at the features of Kubernetes and see how it can be used as part of our Hyperledger application without having to pay any money. So let's click on free and let's give it a nice name. And click on Create Cluster. Now the Kubernetes cluster takes about 20 minutes to be set up. So while this is happening, we can go ahead and create the next two services that we want to create, which is the cloud object storage, and that would be followed by the blockchain platform. So going back to catalog, we can search for cloud object storage. Click on object storage here. Now again, over here there are two options. There's the free option and the standard. We'll just go for the light plan, which is free. And you can give it a name, you can give it any tags if you want, and click on create. Back on the catalog page, let's create the blockchain platform instance. So we'll click on blockchain platform. And you can see here that there's just one plan available, which says that it's 0.29 USD per virtual processor core hours. However, if you if you connect this with a free Kubernetes cluster, then you don't have to pay anything. And that is exactly what we've done. We've already started the creation of a free Kubernetes cluster, which is still being spun out for us. So we can just go ahead with this paid plan for blockchain platform, but we will not be charged. So again, I'm going to leave the service name. You could give any name over here, but I'm going to leave it as is and just click create. So when this is being created, it walks you through a couple of steps. And let's see. So it says welcome. Let's click on let's get set up. And it says create an IBM Cloud Kubernetes Service Cluster. Now we already have one created, right? So we don't need to create this. We could just connect to an existing one. So let's move on to the next stage, which is link in IBM Cloud Kubernetes Service Cluster, and click on next. And it's going to keep checking for an available cluster. And at this point, we do have kube cluster, but it's still in the deploying state. So it won't let you connect to the Kubernetes service cluster at this moment. Remember how I said it would take about 20 minutes? So let's check back in 20 minutes. And once the Kubernetes service cluster has been created for us, we'll come back to this screen and connect blockchain platform with the kube cluster. So we've been waiting for a couple of minutes, and now let's go back and check if our IBM Kubernetes Service cluster has been spun up. So going back to the link in IBM Cloud Kubernetes Service Cluster screen, you can check for kube cluster, and it does not show that error saying it's still in deploying state anymore or pending state anymore. So now that we have that available, we can just select the kube cluster here and click on next. And once that completes, we should be able to move on to the next stage, which is launching the IBM blockchain platform. The cluster has been linked to the IBM blockchain platform instance. Now we can go on and launch the IBM blockchain platform console. Now we can start building our blockchain network on IBM blockchain platform. Let's start by creating a certificate authority for our peer organization. So on the Nodes tab in the left-hand pane, let's select Add Certificate Authority. We're going to create an IBM Cloud Certificate Authority with the display name of org1ca. The enroll ID and enroll secret for this, I'm going to give it as admin and admin PW. You can click Add Certificate Authority to create this new certificate authority. It takes a couple minutes for the certificate authority to set up. This green icon here indicates that the org1ca is now up and running. So now we can go in and associate the org1ca admin identity. So let's click on Associate Identity. Let's give the enroll ID as admin, the secret as admin PW, and we'll give it the name of org1ca identity and click Associate Identity. Once the admin identity has been associated with this CA, we can go in and use the CA for registering identities for org1 admin and peer1. So we'll click on register user and start with org1 admin. with an enroll secret of org1 admin pw. We leave the type of this user as client, and we will use root affiliation. Just let's click on next. And without adding any attributes, we'll click on register user. Next is peer1. So we'll click on register user again and type in peer1 as the enroll ID and peer1 pw as the enroll secret. The type of this particular user is a peer, so we'll change the type, continue using root affiliation as before, and click next and register user. The next step is to create the org1 MSP. So for that, we'll go to the Organizations tab on the left-hand navigation pane and select Create MSP Definition. We'll give the name for this MSP as org1 MSP, and the ID will also be org1 MSP. We'll select the root certificate authority as org1 CA, and the enroll ID and secret would be org1 admin and org1 admin pw. Let's give this identity a name of org1 admin and click generate. We'll export the identity that was created and then click on create MSP definition. Now that the MSP has been created, we can go back to the Notes tab on the left-hand navigation pane and click on Add Peer to create our peer. Let's create an IBM Cloud peer with the name of peer org1. The certificate authority will be org1 CA. The peer enroll ID is peer1, and the secret is peer1 pw. We'll select the organization MSP as org1 MSP and click next. And we will associate the org1 admin identity that we created a few minutes ago with this peer. Once everything is verified, we can click on Add Peer, and that will ensure that a peer is created. The next step is to create the orderer CA and add the ordering service to our network. We'll start by creating an orderer CA. Let's click on Add Certificate Authority and create an IBM Cloud Certificate Authority with the display name of orderer CA, an enroll ID of admin, and an enroll secret of admin pw. Once the orderer CA is up and running, we can go in and register the admin identity. So let's associate the identity called admin with an enroll secret of admin pw. Let's give this identity a display name of orderer CA identity and click associate identity. Once that's done, we can use the CA to register the users for orderer admin and orderer 1. So let's click on register user and create the user for orderer admin with an enroll ID of orderer admin and an enroll secret of orderer admin pw. This user is of the type client, so we'll leave this as client. We'll use root affiliation and click next, and without adding any attributes, we'll click on register user. Next, we will register the user for the orderer. So let's go in and type in orderer 1 as the enroll ID and orderer 1 pw as the enroll secret. The type of this particular user is an orderer, so we'll select that, use root affiliation and click next. Without adding any attributes, we will select register user. The next step is to create the orderer MSP. So for that, we'll go to the Organizations tab on the left-hand pane and select Create MSP Definition. We'll give this MSP the name of orderer MSP with an ID of orderer MSP. We'll select the root certificate authority as orderer CA, and the enroll ID and enroll secret that we'll provide here would be orderer admin and orderer admin pw. The identity that we create, we're going to name it as orderer admin. Let's click generate. Let's export the identity to our local machines and create MSP definition. Now that the MSP has been created, we can go back to the Notes tab and create our ordering service. Let's click on create an IBM Cloud service ordering service and give it the name of orderer. The certificate authority that we select would be orderer CA. The ordering service enroll ID is orderer 1 with the enroll secret of orderer 1 pw. The MSP that we've created is orderer MSP, and the identity that we have created is orderer admin. Let's click Next, verify everything, and click on Add Ordering Service. Once the orderer is up and running, we can go into the orderer and add org1, which is the organization we created a few minutes earlier, as a consortium member to this orderer. So let's click on Add Organization and select org1 MSP and click Add Organization. The next step is to create the channel. In the left-hand navigation pane, let's click on Channels. And on the screen, let's click Create Channel. We'll give the channel name as My Channel and select Orderer as the ordering service. We'll select the channel member to be added as org1 MSP and click on Add. We'll set the permissions as operator, scroll down to Channel Creator MSP and select org1 MSP and the identity as org1 admin and click Create Channel. The next step is to join the channel. So we'll click on Join Channel, select the ordering service, which is Orderer, click Next, type the channel name that we have just created, which is My Channel, and click Next. And then we select the organization to add to this channel. So we need to click on this one over here to see that it has been selected. And once that's done, we can click Join Channel. We can now go in and install our smart contract. So in the left-hand navigation pane, let's select Smart Contracts and click on Install Smart Contract. We can upload the smart contract that we had exported from Visual Studio Code. And once that's done, we can click on Install Smart Contract. Once the smart contract has been installed successfully, the next step is to instantiate the smart contract. So we can click on Instantiate. It will ask us to select the channel that we want to instantiate the smart contract on. Let's select My Channel and click Next. The members that we want to add is org1 MSP, the only member that we have at this point. Click Next. We don't want to set up any private data collection at this point, so let's just skip this step and go to the next screen. In some cases, there are functions which might have to be run when the contract is being instantiated. In our case, there is no function that we want to run at the time, so we leave the function name and arguments as blank and just click on Instantiate Smart Contract. We can scroll down to Instantiate Smart Contracts and select Connect with SDK. Select the MSP as org1 MSP and the certificate authority as org1 CA. And click on Download Connection Profile. It will save the connection profile to your local machine. Next, we will create an application admin which can interact with this application using the SDK. So let's go back to the Nodes tab and go to org1 CA. And in here, we will register a new user called AppAdmin with the enroll secret of AppAdmin PW. The type of this user is a client. We'll use root affiliation and click Next. We'll add a new attribute here called HF registrar roles and enter the value of star and click register user. Now that our blockchain network has been completely set up, we can go ahead and connect the network with our application. For that, we need to go to our downloads folder and locate that connection profile.json that we downloaded from the blockchain platform. We'll have to copy this file to the web apps config folder within the server directory. So web apps server config, that's where we will paste this file. So now this is inside the local copy of the repo for blockchain for maintaining digital assets that we had obtained from GitHub. Now there are some changes that we need to make to the config.json file. Some of these changes are coming from the My Channel blockchain for maintaining digital assets profile.json. Some of them will come from the Mailtrap server that we had set up earlier. And some of them will come from the IBM Cloud Object Storage Service instance that we had set up sometime earlier on IBM Cloud. So let's open these two files in VS Code and start editing them. So I'm going to bring in the web app folder within my repos copy, and I'll open the config.json for editing and the my channel blockchain for maintaining digital assets profile.json because I need to copy values from this file. So now in the config.json, we can leave the channel name the same, which is my channel. That's the name that we had provided for our channel in the blockchain platform. The smart contract name will also remain the same. What needs to change is the connection file. Now the connection file name is here, which is my channel blockchain for maintaining digital assets profile.json. So let me go in and update that. The app admin and app admin secret, since we've provided them as app-admin and app-admin pw in blockchain platform, we're going to leave them as is. The org MSP ID is the peer org's MSP ID, which we had provided as org1 MSP, so we leave that as is. Now the CA name, the peer name, and the orderer name are the three pieces of information that come from the connection profile.json. So let's go in there, and you can scroll down to the certificate authorities section and copy this value, which is the CA name, and provide that here. Likewise, in the peers section, we can find the peer name, and in the orderers section, we can find the orderer name. Lastly, the gateway discovery, that's something we have to set to as localhost false, because we're no longer running this on the local machine, we're running it on IBM Cloud. Now the next four pieces of information, which is the SMTP host, the SMTP port, the SMTP username, and the SMTP password. These bits of information come from mailtrap.io. So let's go to mailtrap.io and go to the inbox that we had created. Now we are going to connect to mailtrap.io using NodeMailer. So under integrations, let's go to NodeMailer, and we can grab these pieces of information from here and add them to our config.json. So the host here becomes the SMTP host. The SMTP port is 2525. The SMTP username is this value here. And the SMTP password is this here. The sender email here is just the email address that will be used to send out emails to all the users in this application. It's a dummy email that I have provided. You can change it if you want, or you can leave it as is. These next four pieces of information come from Cloud Object Storage. So let's go to our IBM Cloud Object Storage instance in order to obtain these pieces of information. So on cloud.ibm.com, let me go to storage. And the Cloud Object Storage instance that I had created earlier. Now in the left-hand navigation pane under buckets, let's go to create bucket. And what we first need to do is essentially create a bucket which will be the place where all of the files that we are uploading to our digital asset management solution, they'll be stored. So we can create buckets in multiple ways. For the purpose of this demonstration, we'll just stick to the standard predefined buckets. So let's click on standard. And you need to give a unique bucket name. Now, a unique bucket name isn't just unique in your instance of Cloud Object Storage, but must be unique across the whole IBM Cloud Object Storage system. So if I have used a name, you will not be able to use the same name for the bucket. So you'll have to make some modifications to it. So what I'm going to do is I'm going to call it my digital asset management bucket. All right. Okay, so I'll click on next, and if this particular name has been used, it would have thrown me an error. It didn't, so I'll move on. I don't want to upload any files at this point, so I'll click next. I don't want to test the bucket out at this point, so I'll click next. and my bucket has been successfully created. So now I can pick up the bucket name from here, which is Digital Asset Management Bucket, and I can add it here to cost bucket name. You can scroll down, and in the service credential section, the API key is what needs to be copied as the COS API key ID, and the resource instance ID is what needs to be copied as the COS service instance ID. Okay. And in the endpoint section, I can grab this, which is the public endpoint for my bucket, and copy that in here. And that's it. We've updated our config.json file, and now we should be able to access the blockchain network, the cloud object storage, as well as Mailtrap server using our application. So let's open a new terminal and go to the web app server folder. And in here, let's install all the node dependencies. Once all the node dependencies have been installed, we can enroll the admin, which we have defined in the config.json file, using the enroll admin.js script. The script is in the server folder, so let's run node enroll admin.js. And it says here that the admin user app admin was successfully enrolled and it was imported into the wallet, which is something we can also see here. Under server config, a new folder called ID wallet has been created, and within it is the app admin, the information for the app admin user, which was just enrolled. So now to start the server, we can run npm start, and that should start our server. Let's now move on to the client. So let me open a new terminal here and go to the client folder under web app. Like in case of the like in case of the server, we can now install the node dependencies using npm install. The node dependencies have been installed, and now we can run npm run serve to start the client. It's building all of the modules required for the client. And now that that's completed, we can go to localhost 8080, and that's where we can see our UI. So now you should be able to go through and perform any actions that you want on the website without any errors. So you can have a look at the intro and demo video, which I have linked in the description below, to see how you can register, log in, and perform various other activities using the digital asset management software, which is linked to blockchain, node mailer, as well as cloud object storage.